Good morning, good afternoon, or good evening. This is going to be a full walkthrough of the January 2019 3H paper. As always, you should be attempting the paper yourself in full before trying to use this guide in any way. We lose a lot of the value of a question the moment we use someone else's hints and or solutions. Without further ado, let's start. Formula page, by now you should be very familiar with what's on there, and we'll check back to it to double check formulas, etc. Starting with question 1. Jerry is driving from London to Leeds with an average speed. We want to work out how long it's going to take him. So speed equals distance over time, rearranging that. Time is distance over speed. Checking the units are correct. It is kilometers per hour and kilometers. So you can do the division into our calculators. And that gives an answer of 4.2. Now there is a button on the calculator which turns that into hours and minutes for us by pressing that button, which is the circle apostrophe style button. That tells us it's 4 hours and 12 minutes. Point A has these coordinates, B has those. We are looking for the midpoint of the line AB. Remembering our formula, the midpoint is the average of the x as the new x coordinate and the average of the y as the new y coordinate. So that's 6.5, 3 as our midpoint there. Question 3, set theory. List the members of the set A, N, B. The N, we remember, means and. So it's the stuff which is in A and also in B. And if we look at the sets A and B, we get 3, 6 and 9 are in both of them. A, U, C, remember the U symbol is the union, the stuff which is in A or C or both. So we need to list all the elements in A and then include all the elements in C, sorry. And notice I'm not going to write the 6 and the 18 again. We only write each element singularly each time. Sasha wrote 12, E crossed out A, so that's saying 12 is not a member of A. And Sasha is correct, as A is because 12 is not in A. Question 4, a circle has a diameter. We want to work out the circumference. We need to remember the formula for circumference is either 2 pi r or just pi d. As I've been given the diameter, I'm going to use pi d. So that's 18 pi, which in my calculator, rounding to 1 decimal place, is 56.5 centimeters. Question 5 looks like a probability question. 40 counters in the bag. We have 18 red, 13 blue, 9 yellow. We're going to put some more red counters into the bag. And then we take a counter out. And the probability it's red is now a half. There's probably some clever ratio style approach to this question. I think the best of this is to use it algebraic. So I'm going to say I'm going to add an extra x red counters, which means we also have an extra x counters in the bag in total. So now the probability of red is 18 plus x over 40 plus x, but we've been told that that probability is a half. I'm first just trying to work out how many extra counters I've added, and then I'll do the rest of the question. This is a fractional equation. I don't like fractions in my equation, so I'm going to multiply up by 2 and multiply up by the 40 plus x. Clear the denominators. Expanding left-hand side. Bringing the x's all to the left and the numbers to the right, we get that x equals 4. So we've added an extra 4 counters to this bag. Well, the question actually wanted the probability of yellow. So yellow was 9 counters now out of the total of 44. And there's no way I can simplify that. That will be my answer. As I said, there's probably some clever ratio style approach, or just we need to add in 4 more counters, then it's 22 red out of 44 in total, and you could have just incremented on the number of red counters until you got that probability of a half. Question 6. Factorize. We have a common y, leave behind y plus 1. Solve. We need to expand out the brackets on the left. We then want to bring all the m's to the same size. So I'm going to add 5m. We always want to, if we do have a negative amount anywhere, we want to clear that. Subtract off the 21, so 8m is negative 9. So m is negative 9 over 8. If I sub that back into the original equation and it's correct, I know I've got the correct answer. Expand and simplify. Let's use FOIL. G squared for the first. The outsides are 2g, the insides minus 7g, and the last minus 14. Collecting the terms in the middle together, and we get r g squared minus 5g minus 14. Write down the inequality on this number line. Notice it's an open circle at minus 4, so we do not include minus 4, but a closed circle at 3, so we do have to include 3. Lots of different skills tested on that page, but all relatively quick. Question 7. There are 96 cards on a table, each are red or black. The ratio of the number of red to black is 5 to 7. We've been told there's a circle on some of the red and a circle on some of the black. We want to know how many circles there are amongst this pack of 96 cards. So let's first work out how many red and how many black. We have the ratio of red to black being 5 to 7. Well, that's a total of 12 parts, making the entire 96 cards. So 1 part dividing 96 by 12 gives us 8 cards per part. So for the red, we have 5 times 8. We have 40 cards. I'm going to follow through with the red before I go and look at the black. 35% of these have a circle. To find 35%, we multiply by 0.35. 40 times 0.35 in my calculator is 14 with circles. And notice I am putting these words in for the sake of the examiner and for the sake of myself. If I come back to check this later on, having a few words in your calculations is really useful. Now for the black was 7 parts, each part being 8, so there are 56 black cards. We've been told that 3/4 of that 56 have circles, so 56 times by 3/4, 3/14 is 12 with circles. So you've got 14 black. We've got another 12. So you've got 14 red with circles. You've got 12 black with circles. So you have a total of 26 cards with a circle on them. Question 8. We're going to try and draw the graph y plus 3x equals 4 from -2 to 3. Now it's up to you with these questions whether you want to create a table of values or whether you prefer to use a gradient and intercept approach. I'll do a table of values here. Feels slightly more consistent. So we have our x and y. I'm not going to do all the values. We know we only actually need 2 values to be able to draw a straight line. I'm going to do 3, the 2 extremes and 0. When x is -2, if I put -2 into that formula, that's y equals -2 times -3 plus 4. That comes out as 10. When I put 0 in, that's -3 times 0 plus 4. That gives us 4. And when I put 3 in, that's y equals -3 times 3 plus 4 is -5. I'm going to plot these carefully on my graph. Unfortunately, the -2 is off the bottom, so I can't even use that data point. But I can use 0, 4, and 3. Oh no, sorry, -210 is up here. 0, 4, and then 3 minus 5. And then you'll have a better chance of getting these lined up nicely with pencil and ruler than I will have on the iPad. Join them up with a nice straight line. Question 9, we have a right angle triangle. We have a side and an angle that's screaming at us. SOHCAHTOA. I'm going to write that at the top of the question before I even read what I need to work out. We want the length of RP. Well, RP is the opposite to that angle. We have the adjacent over here, the 12.7. So we're looking for the ratio which includes opposite and adjacent. Well, that's going to be TOA tan. So we have that tan 52 is equal to the opposite, which is what we want to work out, divided by the adjacent. So the opposite multiplying up is that 12.7 times tan 52. Typing that in gives me an answer. We want it to 3 sig fig, so 16.3 centimeters. Question 10. Emily makes 6 cakes. It's going to cost her a total of £7.60 to make all these cakes. This already feels like a profit style question. 2 of the cakes sold for £3.50. The other were sold for £4.25 each. Work out, indeed, the percentage profit. So let's work out the profit of each. So the 2 cakes at £3.50 each, they gave us £7, and the 4 at £4.25, £4.25 times by 4 gives us £17. So our total income, again I'm writing words so the examiner knows what I'm thinking rather than just having numbers all over the page. My total income is £24, so my profit is at 24, take away how much I paid, which was the £7.60. 24 take away £7.60 gives my profit as £16.40. So my percentage profit is that profit out of how much I paid. And it looks like Emily here has done quite well with her cake sale. £16.40 divided by 7.6. To turn it into a percentage, I need to multiply that solution by 100. And we have a profit to the nearest whole number of 216%. She pretty much trebled her money in this cake sale, which isn't unreasonable for this kind of situation. Question 11. We have a prism. We're looking for the surface area. Well, that means we need to find the area of each and every face. We've been told that the front and back faces are both trapezia, so we need to remember half the sum of the parallel sides times the distance between them. Let's do those first. So this is the front slash the back. We have half the sum, 21 plus 27, times the distance between them. 0.5 times 21 plus 27 times 8. And that gives me the front and back are each 192 centimeters squared. I need to remember later that I should double that. I'm going to go for the left hand side. That's just a rectangle. That's an 8 times 30, 240. We have the top. That seems quite easy. 21 times 30. 21 times 30 is 630. We have the bottom, which is 27 times 30, which is an 810. And we have been told, perfect, the slanted length over there for that right hand side slanted height is 10 times 30, which is 300. So our total surface area is each of those rectangles plus 2 lots of, for the front and the back of the trapezium. So 240 plus 630 plus 810 plus 300 plus 2 lots of 192 gives me a total surface area of 2,364 centimeters squared. Seems reasonable for the situation we have here. Question 12. 40 children at kindergarten, 24 are boys, 16 are girls, and we have some mean heights going on. We want to calculate the mean height of all 40. Well, to calculate mean height of all 40, we need the total height of all 40. So let's work out the total height for the boys. Well, there's 24 of them with an average of 113. Multiplying those gives us the total. So the total height for the boys is 2,712. For the girls, we'll do a similar calculation. There are 16 at 110 each. 16 times 110 is 1,760. So the total height of all of the children are those two added together, 4,472, and therefore the mean is that 4,472 over 40. Hopefully you've noticed by now that you should be getting an answer around 100 and probably 111, 112 because of the, well, it has to be between the 110 and 113 being the means for the boys and girls separately, and indeed it comes out as 111.8. There were more boys, so we do expect the answer to be closer to the boys' height. Question 13. We're investing in a savings account with 1.2%. We need to remember our compound interest formula. The investment times the multiplier. Well, interest is an increase. Increase of 1.2% is 1.012 over 3 years. So we have a power of 3. We want how much money he has at the end of those 3 years. So that's our calculation. Into our calculator, we get 18,655.807. Question wanted it to the nearest unit, so we round that to a 6. Question 14, a cumulative frequency. First asked us to fill in the cumulative frequency table. Cumulative frequency is a running total. 0 to 5 we've got 8. When we go up to 10 we've got an extra 20, so 28. an extra 27 to 55, an extra 29 takes us to 84, extra 18, 102, extra 11, 113, and then finally an extra 7 to get to 120. I'm checking, and yes, the question told us there were 120 people in total, so getting to 120 at the end is a very good sign. Now we need to plot it. We plot at the end points. So we're going to plot that cumulative frequency of 8 at 5. So at 5 we have 8. It appears to be these squares which are going up in 2s. Then we've got 28 at 10. 28 is up there. 55 at 20. Then you've got, oh no, 55 at 15, I apologise. 55 at 15. 84 at 20. 102, 113, 120. 102, 113, well that's 110, 113. I just need to check the boundaries, and we do stop at 35. Okay, so at 35 we're up at 120. Again, with pencil and ruler you'll be able to, well not ruler in this case, but pencil, you'll be able to make a much better job of drawing these up with a small curve than I will. These should not be dot to dot, these should be connected with a nice smooth curve, even though mine does not look great off the iPad. Find an estimate for the interquartile range. Interquartile range, our lower quartile is a quarter of the way up. So the lower quartile, we had 120 divided by 4. Is at the 30th value. So across to the graph and down. It looks about, it should be a little bit more than 10. I missed slightly. So I'm going to go with 11. My graph, you can see, is not too great at that point. The upper quartile is at 3/4 of 120, which is at 90. So looking at my graph, across at 90 and then down. That looks like it's getting to 21. Of course, pencil and ruler will make this more consistent. Interquartile range, 21 minus 11. This is an interquartile range of 10 kilometers. Question 15. Here's our algebra question, checking all of our basic algebra skills. We've got a division of indices. When we divide, we subtract the powers. Multiplying, multiply the numbers, add the powers of the letters, noticing that there is a hidden power 1 on that second E. Indices to a power, the number to a power of half, well that's the square root of 64 is 8. And we multiply the power 6 times a half for 3 there, and 2 times a half, well that's just power 1. We don't write power 1, or we don't need to write power 1. Factorize, one of our favorites here. This is a difference of 2 squares, x plus 1, x minus 1. And then a rearrange, make k the subject. Last thing that happened on the right hand side was the square root, so let's square both sides to start. Again, last thing that happened was to divide by 3, so let's multiply both sides by 3. The k is what we're aiming for. I'm going to move the 2k to the left and the 3f squared back the other way. I don't really want to have my k term being negative. And then finally, divide, and I've already typoed here. Finally, divide by that 2 that was in front of the k. And leaving it as a large fraction is perfect. Question 16. Similar triangles. We have an embedded triangle here. We've got the smaller triangle ARB with sides of 5 and 6. Then we've got the larger triangle PRQ, which has a base of 15, and that's all we know about PRQ. We have just some information telling us that A is on PR, B is on QR, and we've got these parallel lines. We want to work out the length of A to P. This A to P is just the little length here, so if I can find the length P to R, I can then subtract 5 and be very happy. Well, first I need the scale factor. Scale factor using corresponding size, 15/6 are the two which match up, which simplifies to 5/2. So then the whole length PR is 5/2 lots of the small version, which was AR, which was 5, is 12.5. So therefore the length I actually care about, AP, is the entire 12.5 that we've just worked out. Take away the 5 is 7.5. We have an area statement now, so immediately we should be thinking about squaring our scale factor to make it into an area scale factor. So area scale factor will be that 5/2 squared, 25/4. Can of course be working in decimals if you wish at that point. We have the area PQR, which is the large triangle, and we want the area of the smaller triangle, so the area of ARB, is going to be that 88 divided by this scale factor. We're looking for the smaller triangle. 88 divided by 25/4 gives me 14.08 centimeters squared. Question 17. Use algebra to show the reoccurring decimal is. Our trick here is to let x be that recurring decimal. And notice, because of the dots, only the 2 and 4 repeat. I like at this point to write out the repeating part a few times. Our aim is to get that repeating part firstly in front of the decimal place. To do that, we need to move decimal place 3 spots. So it'll be 24.2424 with 1000x. We need to find a multiple of x where the decimal places match up, and that will be timesing by 10. Then all our decimal places line up. Subtracting these two statements, 990x is 24, and all the decimal places disappear. That was the point of that technique. So x is 24/990, and I'm hoping that this simplifies, and I'm going to tell the examiner what I think the simplification is going to be. It's a divide by 6 on the top, and if I check in my calculator, 990 divided by 6 does indeed give the 165 for the denominator, and I'm sorted. Question 18. A vector question, very early in the paper, this vector question, but then it's not the proof style. Right, 2b minus c is a column vector, 2 lots of 3, 2, take away 4 minus 2. Well, let's just work on the top component and bottom component separately. On the top, I've got 2 times 3, take away 4, and on the bottom component, I've got 2 times 2, take away a minus 2, so that's a plus 2. So that should be 2, 6. Cho says the vector is parallel to the vector. So let's work out the vector a minus b first. Well, a minus b is negative 8 on the top, 6 minus 2, 4 on the bottom. And we'll notice that that is minus 2 lots of 4 negative 2. If I times both top and bottom of that by negative 2, I get the a minus b. Well, that's minus 2 lots of c. Well, then a minus b is a multiple of c, so yes, a minus b is parallel to c. We've shown that those two vectors are a scalar multiple of one another, hence they are parallel. Question 19, algebraic fractions. Express that as a single fraction. We need a common denominator first. Our common denominator with algebraic fractions normally is just the two fractions multiplied together. To make the first fraction work, I needed to times it by x plus 5. To make the second fraction work, I needed to multiply it by the 2x plus 1. And I've already combined them together as well. Now we need to carefully expand our numerator brackets. Well, it's minus 3 times 2x and minus 3 times 1. Still over the same denominator. Simplifying the top, I'm going to have minus 5, and then 5 minus 3 plus 2 over the denominator. Nothing's going to cancel here. The top doesn't factorize, so I can't see any way we can kill either of the brackets from the bottom, and we're done. Solve the inequality. This is quite a tough one because this is officially a quadratic inequality. One thing I'm going to do first though is notice the common factor of 6. So I can divide through by 6. Being a quadratic, we should expand and make equal to 0. So I've expanded that double bracket. I'm going to subtract 4 to make it equal to 0, or in this case greater than 0. To solve quadratic inequalities, we're trying to solve it or sketch it and then look for which area. So factorizing the left gives me solutions of 3 and minus 1. Well, we have from that line there a quadratic with solutions at minus 1 and 3. And we want that quadratic to be greater than 0. So that's looking for the region over there and region over there where the curve is above the x-axis. So my solution, x has to be greater than 3 or x is less than minus 1 to describe those two regions. Question 20, a circle theorem. We have A, B, and C on a circle. We have TAP, a tangent, and TBOC is a straight line. And we have a single angle in there. We want to try and work out the angle X. Well, that's maybe not immediately obvious. And this is where we try and think carefully about how to add in the information that we need. Well, certainly I can add in the line O to A. Often quite useful to add in lines into these problems. And then we'll notice that OAT, well, that's a right angle there because the tangent meets the radius at 90. I've just worked out an angle, so I have to say that and give the reason. OAT equals 90 degrees as tangent meets radius at 90. Well, what else could I now work out? Well, it looks like I'm going to be using the triangle TAO. So if I can work out the other angle down at O, I'll be able to use triangles add up to 180. Well, indeed, I know the angle up here is also 29. So that's angle CAO equals 29 as OAC triangle is isosceles. Isosceles because it has two radii. Well, then I can find the angle at AOC. AOC is 180, take away 29, take away the other 29. 180, take away those two, gives that angle is 122 as angles in a triangle add to 180. Well, now that I know that that angle there is 122, the angle on the other side has to be 58, because those angles add up to 180 as well. So that's angle AOT is 180 minus 122 is 58. Angles on a straight line add to 180. And then finally I can work out the value of x. So then ATO is 180, take away the 90 that we noticed right at the start, take away the 58 that we've just calculated. 180 take away 90 take away 58 gives an angle of 32. And the reason there again is angles in a triangle add to 180. Again, notice that every step I did, I justified with one of my reasons, my angle reasons. We didn't actually really use many circle theorems there at all for that question. Question 21. We have functions, f and g. We want to work out f of 3 to start with. Well, f of 3 is just sub 3 into f. F is a half x, which is now 3, plus 3, so that gives an answer of 4.5. State the value of x which cannot be included in any domain of G. So it's asking what value of x am I not allowed to use? Well, I'm not allowed to divide by 0. So that value is when the denominator is 0. So that's when x is 3 over 2. And that value must be excluded from every possible domain. I can never sub 3 over 2 into G. Solve f inverse equals GF. Now this is quite a bit of work, and we look down, this is going to be worth 6 marks eventually, because we don't have either of those functions yet. So let's work out those two functions first. We'll put them equal to each other and hope we can solve it. F inverse, well, that means we need to set f to be a value and rearrange. So take away 3 times by 2. So f inverse of x is 2x minus 6. Notice I did change the letter back to x at the end. GF, well, that's g of f. F was a half x plus 3. So that is 14 over 2 lots of a half x plus 3 minus 3. Let's try and simplify this a little bit. Expanding out the denominator, we have x plus 6 minus 3. Cleaning up the denominator, x plus 3. So now I have my f inverse and I have my GF. We want to solve when these two things are equal. So that's when 2x minus 6 equals 14 over x plus 3. I don't like fractions. I'm going to multiply up, noting that I have put brackets in here as I'm multiplying the whole of the 2x minus 6 by the x plus 3. Expanding that out, 2x squared minus 6x plus 6x minus 18 equals 14. Notice there was some difference of 2 squares cleverness that you may have spotted early. I'm going to throw the 18 over. So that's 2x squared equals 32. Notice the 6x's have cancelled. So x squared equals 16 and x is plus or minus 4. Double checking that there were no extra constraints on f or g. There weren't, so both of those are valid answers. We have a diagram of a parallelogram. We want the area of such. We've been told an extra length, which isn't on the picture, so I'm going to draw that in. that is a 13.3. Well, to find the area of parallelogram, we've already kind of got the hint here. You can find the area of each of its two triangles, and those two triangles will be identical. But to find the area of a triangle without a right angle, we need to use half AB sine C, so we need an angle. So I'm going to try and work out this angle down here. Well, that is in a triangle with all three sides known. So that implies cosine rule. Either by memorizing it or by rearranging the cosine rule, we get that the cos of the angle is b squared plus c squared minus a squared all over 2bc. And notice that we have the opposite pair. So this one over here is the A in this calculation. If this down here is my capital A angle. So that is the 14.6 squared plus 7.5 squared minus 13.3 squared all over 2 lots of 14.6 times 7.5. Quite an unpleasant fraction. Be very careful typing it into your calculator. I advise hitting the fraction button first, typing in the numerator, typing in the denominator, and we get that section is 0.4224, and that goes on forever. But that was cos of the angle, so I need to cos inverse to get that angle, cos inverse of that answer. So that's 65.009, etc. A good hint that you're doing something roughly right when your answer comes out with 0.00 or something 0.00. That's my angle down at P. So now the area is going to be 2 lots of the triangle, and we're using the formula half AB sine C. So that's 2 lots of a half of 7.5, 14.6 times sine of that 65, etc. And notice I have kind of snuck in here that I've relabeled the triangle. This formula is mostly used when you have this side angle side set up. So I have really relabeled the triangle quite sneakily in my head there. Typing all that into our calculator, 2 times a half times 7.5 times 14.6 times sine of the answer, so that'll be the last thing in my calculator, gives me 99.24, etc. Checking how the question wants the answer to 3 significant figures, we get our answer of 99.2. Question 23, bounds. We have a calculation for m. I'm a big fan of writing all the bounds first. So my bounds for A, 5.25, 5.35. My bounds for B, 346.55 to 346.65. C, it's quite a nasty one this, 79.95 and 80.05. And to check that all of these do indeed round to the correct A, B and C to 1 decimal place, is a good check that we've got that right. We want the upper bound of m. We want to make m as big as possible, so we should be choosing to use the upper bound of B. We want to take off the smallest c, and we want to divide by the smallest a. So that is 346.65, take away 79.95, divided by 5.25. Notice I'm trying to be as clear as I possibly can with the examiner with these calculations, telling them exactly what I've chosen to use and then making it clear that I am using the right values as well. And that conveniently comes out straight away to 1 dp without any worries at all there. Question 24, and this is our final question on the paper. So this one is going to take a lot of effort. We have some white and black counters in box X, white and black counters in box Y. We are taking 2 counters from X and putting them into Y, and then we take 1 counter from Y to put it back into X. We want an equal number of white and black in Y. So if we think carefully, Y did have 7 in there. I'm taking 2 out of X into Y, that'll make 9 in Y, and then we lose 1. So we need box Y to have 4 white and 4 black at the end of this problem. There are lots of ways to attack this problem. I think the best will be to have a tree diagram. We're doing things one after the other. And it's going to be quite a large tree diagram actually. So we're taking 1 out of X, another 1 out of X, and then we're going to take 1 out of Y. So out of X I could take a black or a white, and each of those could be black or white, black or white. So those will give me my 2 coming out of box X. And then for each of those I can either take a black or a white, a black or a white out of Y. And in each of these situations, we're unfortunately going to have quite different probabilities. I'm going to fill in all the X ones first, and then we'll think about, do we need all of the Y ones? So we originally had 3 to 5, so that's 3/8, 5/8. If I take a black one out, I've only got 2 black left, so 2/7. I still got all 5 white. If I took a white out, I still have 3 blacks, but now only 4 whites. Now if I take out 2 black out of X, put it into Y, that means there are 5 black tokens in Y and 4 white. If I take a white and a black out of X, that means I've got 4 black, 5 white, 4 black, 5 white. And same for the combination here, 4 white, 4 black, 5 white. If I take 2 white out of box X, that means I've got 3 black and 6 white. Now remember what we said, we want to have 4 white and 4 black in box Y at the end. So which of these branches are actually relevant? Well, the top branches, because there we had 5 black, 4 white, and I need to take a black out. So that one's going to be useful. The second one isn't, because if I take a white out, that'll leave 5 black, 3 white, not equal. Similarly with the next one down, that one's not useful, because if I take a black out, I've got 3 black, 5 white. However, that one is, and so is that one. And the final section, not useful at all. None of those, if I take an extra black out or an extra white out, I don't get back down to the 4-4 split. So those are all of my combinations which will lead to equal white and black. Well, we remember for a tree diagram we multiply across to work out the probabilities. So for that top branch, that's our calculation. For the second useful branch, it was 3/8 to get the black first, 5/7 to get the white, and then 5/9 to get a white. And then for the final useful branch, we took 5/8 first for the white, then we took 3/7 for the black, and then 5/9. Notice the denominators are all the same here, so if you do want to try and be sneaky to save work in your calculator, you can just work out the numerators and then put them all over the right denominator. So my numerator comes out as 180, and then it's over 7 times 8 times 9, which is 504. I'm going to type that in as a whole fraction to get the simplest version. Comes out as 5 over 14 as that probability. And there might have been other ways to, well, there's definitely other ways to set up the problem. I quite like the tree diagram as a very clear setup, a very clear approach to any problem which has multiple things happening one after the other. That does bring us to the end of the paper. As always, if you have spotted any mistakes or problems or have further questions, please do let me know. Otherwise, have a wonderful rest of your day.